So, today we are going to discuss on the time of emptying a rectangular tank through an orifice at its bottom. So you can see a rectangular tank here. The orifice is being provided at the base and you can see the discharge of the liquid. So the water is being filled up to this point. So this is the free water surface of the tank. So here we are going to consider the two liquid levels. After a time t, the water will flow through the orifice and the initial height h1 is decreased to the new height h2 for a time t. Okay, so the initial height is h1 and the final height is h2 after a time t since the water passes through the orifice. So in order to get the time of emptying of this rectangular tank, we will be considering a section as shown here at a depth of h from the bottom surface, the bottom or from the orifice. So the depth of this section from the orifice is small letter h and let dh be the thickness of this section. Okay, so here we are going to consider the area of the orifice tank as capital A. Let it be cylindrical or rectangular in shape. I think in your syllabus it is given as a rectangular. Then the area of orifice, it can be circular, square or rectangle. It is denoted by small letter a. Let h1 be the initial height of liquid and h2 be the final height of liquid, and the time taken for the tank to move from h1 to h2 is capital T. And small h is the height of liquid above the orifice in the tank, and dh is the small interval time. The liquid falls from h at a small interval time dt. So the theoretical velocity, we know the formula, it is root 2gh, and the discharge is area of orifice into the theoretical velocity root 2gh. So that is the theoretical discharge. So in order to get the actual discharge, we have to multiply it with CD. So therefore, the volume of the liquid discharged is equal to the actual discharge into time taken. You know it, right? So the volume of liquid discharge, actual discharge, you know the formula, into time taken as dt. So from the cross-sectional area of the tank, the fall of liquid in the tank, we can calculate the volume of liquid discharge through it. So the volume of liquid discharge through a time dt second is minus a into dh. So why this minus I means the height of the liquid is decreasing with the increase of time. So we can equate both the volume, that is as per the actual discharge value, and with respect to time, we can equate both and get the value of dt like this. And by integrating from 0 to 2 dt, you will be getting the expression for capital T as 2a by CD a root 2g into root of h1 minus root h2. h1 is the initial height and h2 is the final height after the time t. A is the area of the tank, small a is the area of orifice, and CD is the coefficient of discharge. So this is the formula. And here there is a problem, you can see. A cylindrical tank of diameter 1.25 meter. So the diameter of the tank is given, from which you can calculate the capital A value. And the circular orifice diameter is given, from which you can calculate the small a value. From the flow, when the flow of water was shut off, it took 195. The time is given there. And the height h1 and h2 is being given there. Estimate the mean value of the discharge coefficient for the orifice. So CD value you have to calculate. Also, you have to calculate the discharge through the orifice if the orifice head is maintained steady at a 1.5 meter. That is, if the steady orifice means capital H remains constant, and that is 1.5 meter. So you have to do it as two cases. In the first case, directly the expression you have to substitute the value for T, H1, H2, a small letter a and capital A, and you have to get the value of CD. In the second case, the H value you have to keep it as a constant, and you have to get the value of Q actual by using the formula CD A root 2GH, from which you will be getting the actual discharge. Okay. Similarly, there is another problem. Just go through the problem. It is a big tank of 8 meter by 6 meter, which consists of a depth of water 1.5 meter is given. The opening of the orifice, this is square orifice, is being given here, and the coefficient of discharge is given, and the time required to empty the tank. You have to calculate capital T value. So I think you can do the problem by yourself.